Hi, can you hear me?
Yes, sir.
Okay. Can you see the screen?
Yes, sir.
So, um, okay. So before starting, let me know. Do you have any confusion or doubts?
Nothing as such. I just wanted to see how the problem solving goes.
Okay. Okay. So, yeah. So, today we will start with yeah. Today we will start with series. Okay. So first we start with some basic series and look at the convergence. Then we gradually start by using some kind of theorems. So consider the following series. So, so consider the following series summation 1 by n into n plus 1. Now the question is, what is the value of this series? Okay. So, mm,
So,
yeah,
what
yeah.
you're writing, it's not really visible.
Oh, it isn't visible. Okay, okay. Sorry. One second. Now, can you see this?
Yes, sir.
Okay. So consider the following series summation 1 by n into n plus 1. So we need to find that what is the value of the summation or n is the particular one. So this series is basically nothing like 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus dot dot dot. Okay. So consider the nth partial sum Sn. This is what? This will be equal to 1 plus 1 by 2 plus 1 by 2 dot 3 plus 1 by 3 dot 4 plus dot up to nth term 1 by n into n plus 1. So we can write this as follows. 1 can be written as 2 minus 1, 1 dot 2. This can be written as 3 minus 2 by 2 dot 3 plus like this and dot 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 plus n plus 1 minus 1 by n into n plus 1. So this thing can be written as 1 minus half plus half minus 1/3 plus 1/3 minus 1/4 plus dot 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 once again plus dot 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 1 by n minus 1 by n plus 1. So by cancellation this thing gives 1 minus 1 by n plus 1. So the value of this limit Sn into infinity is 1. So the value of this summation 1 by n into n plus 1 is equal to 1. So in this way we can solve this type of problems. But of course some series cannot be, I mean for some series it's not possible to always get the value. So in some situations we need to only consider whether series converges or not. Okay, so we'll see the example soon. So yeah, consider the following, sorry. So consider the following example. So consider consider the series 1 plus half plus half square plus half cube plus dot dot dot. What is the value of it? So same way, put Sn is equal to 1 plus half square 1 by 2 plus dot 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 plus 1 by 2 to the power n. So we have already a formula which is nothing but so the first term is 1 minus 2 to the power n plus 1 by 1 minus half. So this is nothing but 2 into 1 minus 1 by n to the power n plus 1. This is nothing but 2 minus 1 by 2 to the power n. So and obviously this goes to 2 as n tending to infinity. So this series summation 1 by 2 to the power n is equal to 2. So now consider the consider of this example. Okay, so do you understand the first two problems?
Yes, sir.
Okay. Consider third problem. Mm, So show that following series diverges. The series is 1 plus half plus 1 third plus 1 fourth dot dot dot. We need to check this series diverges. So by definition, we need to check the nth partial sum diverges by definition. We need to check this. Okay, sorry. I mean, it's not a solution. The point is that we need to check that whether we need to check that nth partial sum diverges or not. Okay. So Sn is what? Sn is 1 plus half plus 1 third plus 1 fourth plus dot 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 plus 1 by. Now consider the subsequence s2 to the power n. So what is s2? S2 is equal to 1 plus half. What is s4? S4 is equal to 1 plus half plus 1 third plus 1 fourth. This is greater than 1 plus half plus 1 by 4 plus 1 by 4. This is equal to 1 plus 2 into half. Now consider S8. 1 plus half plus 1 third 1 fourth. We are keeping it together. Plus 1 5 1 6 1 7 1 8. This is equal to, I mean, this is actually greater than 1 plus half plus 1 third is greater than 1 by 4. So that's why this thing. And rest of the portion will be replaced by 1 by h. So this is greater than, I mean, this is equal to 1 plus 3 into 1 by 2. So similarly, A16 is greater than 1 plus 4 into 1 by 2. So S should be greater than 1 plus n by 2, which diverges as intended. So we see that partial the subsequence S2 and diverges, so the sequence Sn diverges. Hence the this series 1 half 1 third 1 fourth, this series diverges. Okay. So do you understand this process?
So we compare SN another series and then we
Sorry, can you
come to
please
that
repeat?
conclusion.
Can you please repeat?
Yes, sir. So we compare SN. another sequence and then we come to that conclusion.
Yes, yes. I mean, we are not actually comparing. We are considering the sequence SN, then we are considering its one of its subsequence, and we are getting that its subsequence is diverges. Say hence the main sequence diverges. Okay.
Oh, okay.
So, one second. So now, yeah. So, yeah. So now consider the following question, which tells that the proof that series that the series 1 minus half plus 1/3 minus 1/4 plus dot 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 1%. Just remember, just note one thing, that this series is alternating. The signs are here alternating. So this is convergent, and in the previous problem, signs, I mean, all sign are positive, and this divergent. So this series, this first one is known as uh, harmonic series. The second one is known as alternating series. So, okay, so, well, can you just try for 1 2 minutes, or if you are not getting the point answer, then I will show you how to prove this type of problems. Okay. Or can you tell how to solve this problem? Any idea? Let's try for 2 3 minutes. Okay, so, well, so let's see how to solve this type of problems. Okay. So, so first, the main technical tool that is needed here is the Cauchy criteria of convergence. Okay. This is the main technical tool here. Okay. So, how to use it? So, let's let's assume this series be summation even. Okay. Then un is equal to minus 1 to the power n plus 1 1 by n. Hmm? And consider is Sn, there is the partial, so it is not the partial sum. I should write it before. Okay, sorry for that. So it is not the partial. Sn is equal to u1, u2, un. Then observe that Sn plus p minus Sn is equal to mod of 1 by n plus 1 minus 1 by n plus 2 plus dot 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 plus minus 1 to the power p minus 1 1 by n plus p. So this can be written as 1 by n plus 1 minus 1 by n plus 2 minus 1 by n plus 3 minus dot dot dot. So this thing obviously this is less than n plus 1. So we see that Sn plus p minus Sn is less than n plus 1. And this thing goes to 0. So by Cauchy criteria, the sequence Sn convergent by Cauchy criteria. So this alternating series converges. So in this way, you can solve this problem. So just I am repeating this solution again. So first we need to show the convergence. So here we are going to use the Cauchy criteria as the main technical tool. Okay. So we are rewriting the sequence as Sn is equal to summation un, where un is each term minus 1 to the power n plus 1.5. Now we are going to apply the Cauchy criteria. That is, we are looking to this absolute value of Sn plus p minus Sn, which is equal to mod of 1 by n plus 1 minus 1 by n plus 2 plus dot dot minus 1 to the power p minus 1 1 by n plus 1, which is equal to mod of 1 by n plus 1 minus 1 by n plus 2 minus 1 by minus dot dot dot. And we are getting that this thing is less than 1 by n plus 1, and this converges 0. So by Cauchy criteria, this series minus 1 to the n plus 1 is convergent. So just let me know whether you have any confusion in the solution or not. I'm waiting for 3 minutes. Okay.
So could you scroll up a bit?
Yeah, sure.
So, how do
So
we
how
get
do
the
we get the
intuition that
intuition
we need
that
to
we
use
need to
Cauchy's
use cautious
criterion for
criteria
questions
for
like these
questions
and
like these?
stuff like that?
Actually, it's a matter of practice. Okay, I can understand because I know this, but for the first some months you are obviously going to struggle at how to get the intuition. But as long as you practice minimal problems, you will get the intuition as much as you practice the problems. Okay, there is no way to solve this. There is no way to answer this actually. Or also actually the thing is, after some minutes we are going to see some theorems. From those theorems we will actually see, I mean, there is one theorem which directly tells us that this series will converge. So that's how we make guess actually, but there is no hard and fast rule.
Okay,
Only
sir.
it's a matter of practice. Okay, so yeah, so moving to the next problem. One second. Yeah. So, do you know one fact that if a series summation even convergent, then its limiting value will be zero? Hmm.
So, could you
So
repeat
could
that?
you
Yeah, let me write it down. So, if summation even convergent, this implies limit even zero. Do you know this?
Yes, sir.
Yes.
Okay. So, now the next problem will be based on this. Okay. So, the problem is that show that summation n by n plus 1 divergent. So, I mean, obviously, you can see that this limiting value is 1, which is non-zero. So, this series divergent. Okay, so, one second. So, have you done comparison test? Do you know the theory of the comparison test, limit test?
Yes, sir. The five
Yes, sir.
comparison
Yes,
tests.
sir. Okay, okay. So, yeah, answer the following problem. Show that this following series convergent using comparison test, using comparison or limit test. Just try for some minutes. First, you try to realize the each term in. I mean, first you try to write down the nth term of this series, and then try to use comparison test or limit test by using some known series. Just try it first, or else I will give a hint. Okay, so the hint is the following. Consider the series summation 1 by n and use limit test. Now try using this hint. If not, then I will do it. Okay, just try. So let's do it. How to solve this circuit. So now observe that if we call this given series as summation un, then the nth term is un is equal to n plus 1, sorry, to n plus 2 by 2 into n plus 1 whole cube. Okay. Now, and consider Vn is equal to 1 by n. Now, consider un by Vn. This is what? This is limit. Sorry, this will be equal to n into n plus 2 by 2 into n plus 1 whole square. So, what is the value of limit un plus Vn? This value is 1 by 2, which is non-zero. So the limit test is now, as since summation 1 by n diverges, so limit test is the given series summation even also diverge. Sorry. So do so everyone understand this? So the main technique is that we have used the sequence Vn is equal to 1 by n, and then we use the limit test. So I mean, so in this problem, anybody can ask that how we can guess that we need to consider the sequence Vn, or we need to consider any particular chosen sequence. The point is, it's only a matter of practice. As much as you practice, you will get to understand which sequence is needed to be used. Okay. So does everyone understand this? Once. Yeah. So I hope that everybody understands this. So going to the next problem. Based on the convergence of the series 1 by 1 dot 2 square plus 1 by 2 dot 3 square plus 1 by 3 dot 4 square plus dot dot dot. So yeah, first of all, this series will be convergent. So also, I mean, here you here only we need to use the comparison of limit test. First, you try for some minutes. If not, I will give you it. Then I will solve. Okay. First, try to realize the general term is 1 by n into n plus 1 whole square. Now, somehow try to use limit test or comparison test by using. Sorry,
நார்மல் ஃபிகர் இல்லையா
sorry. Actually, your
பாத்
voice distorted.
என்னது
Sorry, your voice distorted. So, can anybody please try?
So can we choose a Bn to be 1 by n cube?
Yeah, very good, Mega. Yeah, so this works.
ம்
So, as Mega told, then
வந்துருச்சா
then the
யா
limiting value will be 1, right?
ஆ என்னது
1 second. I need to mute
புரியல
someone.
ஆ ஒரே நிமிஷம் இருங்க நான் பாக்குறேன் லாஸ்ட் இதுல என்ன
1 second.
எவ்ரி ஒன்ல தான் இருக்கு எவ்ரி ஒன்ல தான் இருக்கு அழிச்சிடுறேன் ம் ம் சொல்லுங்க ஒன்றும் இல்லையா சரி என்னென்ன
Lagosuri, can you please mute yourself?
புரியல நான் வேற நெட் ஆஃப் பண்ணிட்டேன் மூதி வேறு கத்தாது
Lagosuri, can you please mute yourself?
இது சனியா அவ கிளாஸ் போட்டு
Yeah, so coming to the problem. So here the limit even by Vn is equal to 1. So as Mega, sorry, once again. So as she told, yeah, so now since summation Vn convergent, so summation even is convergent. Yeah, that's very good. So Ninad, do you understand this or the previous problem? Do you understand?
Yes.
So consider the next problem. Test the convergence of the series even is equal to root over n4 plus 1 minus root over n4 minus 1. This converges or not. Do it using only limit test or comparison test. First of all, the thing is try to rationalize this. Try to rationalize even. Then try to find Vn. First you try, or else I will tell you how to do this. Okay. It is not difficult, but first try to rationalize un. So by do you understand what does it mean by rationalize un?
Yes, sir.
Okay. So rationalize it and then try to realize which vn should we choose. Just try it.
Maybe 1 by n square.
I also don't know. I mean, I need to. Okay. So need to rationalize even. So even will be, so yeah. So even will be root over n4 plus 1 plus root over n4 minus 1. Yeah. So they were correct. So we need to choose Vn is equal to 1 by n squared, and in that case the limiting value of unv, sorry, unvn goes to 1. So this even summation convergent as summation 1 by n square. Yeah, very good. So, mm, now, so do you know about ratio test? Do you know about ratio test?
Sir, do you mean the D'Alembert's ratio
Yes, yes,
test?
right, right, right. So, mm, so, okay, so as an application, consider the following. I mean, test the convergence of the following series: 1 plus 3 by 2 factorial plus 5 by 3 factorial plus 7 by 4 factorial plus dot dot dot. And do it using the D'Alembert's ratio test. So just you try it and let me know whether it's converging or not. Is anybody trying? Okay, so well, so let's do it. So here UN is
So
equal to, yeah,
it'll
tell me.
be convergent, sir.
Yeah, you're right. That's good. So what about Dina?
Yes, sir, it is convergent.
Yeah,
In
yeah. So and do you know about Cauchy's root test? Do you know about Cauchy's root test? Okay, there. Okay, well. So let me state it. Sorry. This theorem states that they consider the series summation event where UN are, sorry, all are positive, UN is greater than 0, and if limit n tend to infinity, UN to the power 1 by n is equal to L, then summation UN convergent if L is less than 1, and divergent if L is greater than 1. Okay. So this is statement Cauchy's root test. So using this, consider the, so using this, comment on the convergence on the following series. 1 plus 1 by 2 cube plus 1 by 2 square plus 1 by 2 5 plus 1 by 2 to the 4 plus dot dot dot. So comment on this on the convergence. Use the cosine root test. So just try it. So just try it. If you're not getting it, then let me know.
It'll be conversion, sir.
Yeah, right. So very good, Mira. So what is the general term?
1 by 2 power n.
Then
We have to take the nth root of 1 and then take the limit.
no. First of all, tell me what is the nth term of the series?
Oh, I just took 1 by 2 power n as the nth term.
Yeah, okay, no issue. So just try it again. Try and let me know. What about Ninam?
Still working on the nth term, sir.
Okay.
Sir, is the nth term 1 by 2 power n minus 1?
So you are asking, so you are telling that one way to do it. So are you telling this?
Because the order of the terms doesn't really matter in the sum. So
First of all, you have assumed that order of the term doesn't matter, but whenever the series is given, is known to us that is convergent, then only this order does not matter. Okay, but we are trying to check that it is convergent or not. So here it matters. So try to realize the nth term. Omega, are you getting the nth term?
Not really, sir.
Okay, so let me write it down. Nth term is equal to 1 by n plus minus 1 to the power. So this is the nth term. And now if you apply in, if you power it 1 by n, so this will be 2 to the power 1 plus minus 1 to the power n by n and to the 1 minus 1. And will convert this to half, which is less than 1. So the given series convergent. Understand? Do you understand this?
Yes, sir.
Sir.
The next problem. So do you know about the general form of ratio test?
Could you repeat that, sir?
Yeah. Do you know about the general form of ratio test? General form.
No.
As follows. One second. The statement as follows that if summation bn is consider the series summation un and assume that un is greater than 0. Now consider the lim sup of this ratio and consider the lim inf of this ratio. Now if this series convergent if this capital less than 0 and divergent if is small r is greater than 1. So this is the general statement of the ratio test. Okay. So do you know about the lim sup lim inf?
No, sir.
Okay, then leave this form. Okay, then leave it for the time being. So wait. So do you know about Cauchy's condensation test? Know about Cauchy's condensation test?
No, sir.
So let me know the statement. The instrument is that let Fn be monotone decreasing. Let Fn be a mono decreasing sequence of positive real numbers and A be a positive and this A be a, and okay, let me write it down shortly and let A greater than 0. Sorry, let A greater than 0 and A belongs to N. That is A is an integer greater than 1. Then Cauchy's condensation test tells that Then consider this summation fn, then this summation fn, and this summation a to the power n, f of a to the power n converges or diverges together. Okay, that is the statement. If fn is more than decreasing of positive real numbers, and if a is an integer greater than 1, then summation fn and summation a to the power fn converges, diverges together. So, well, so now, so using this, prove the show the following. So prove that summation 1 by n divergent. Well, at the starting we have proved that summation 1 is divergent by using the definition. Now by using Cauchy's condition test, prove that this summation 1 by n is divergent. So just I'm giving you a hint. Put take a to be 2. Now directly use the Cauchy's condition test and get the answer. Just do it. Whenever any of you get the answer, let me know. Does anybody get the answer?
Yes.
Yeah, very good, Megha. And what about Ninad?
Well, I'm not able to get it.
Okay. So, so here fn is equal to 1 by n, and this 1 by n is more than decreasing. This down arrow means more than decreasing. Okay. Now consider this 2 to the power n, f of 2 to the power n. This will be what? This will be 2 to the power n into 1 by 2 to the power n. This is 1. Now obviously this is summation 1 is divergent, right? So this given is summation 1 by n divergent. You understand enough?
Yes, sir. Got it.
So now consider the following. Now comment on the convergence on summation 1 by n to the power p 1 to infinity p greater than 0. Well, it can be done in other way using the comparison test, and I think that you may know it. Okay, but using cautious condensation test, just prove that whatever you know, that is for p greater than 1, this is convergent, and for p less than 1, this is divergent. So yeah, just do it. So just hint is here, put a is equal to 2. Just try it now. Whenever anybody of you are done, let me know. Try it and let me know. What about Logosuri? Are you trying this? So Mega or Nina, anyone for the answer?
It is convergence.
Yeah, for which P? For which P?
For any p greater than 0 really.
No, no. Just check it again. Check it your solution again. Well,
So p
wait.
greater than 1, sorry.
Yeah, right. And what about Megha?
The inequality part, I'm a little confused.
Sorry, I didn't get you.
The inequality part, sir, there I'm confused.
So you are confused with the P greater than 1, P less than 1 part, right?
Yes, sir. How do we get that?
Yeah, yeah. So, well, so first start with any P. So now, so consider the 2 to the power f of 2 to the power n. This is nothing but 1 by 2 to the power n into P minus 1. So now consider the series summation 1 by 2 to the power P minus 1 whole to the power n. First of all, this is a geometric progression, right? And obviously everybody knows that this convergent only if 1 by 2 to the power P minus 1 is less than 1, right?
Yes, sir.
So this implies what? This implies P greater than 1. First this implies P minus 1 greater than 0, and then this means P greater than 1. So P greater than 1 is convergent, and for P less than 1, it is divergent. Okay? You understand?
Yes, sir.
So now, consider the convergence of the following. So now comment on the convergence on summation 2 to infinity 1 by n log n whole to the power p greater than 1. Comment on the convergence of this following series. Try it and let me know. And whenever anybody of you are done, let me know. Anybody got the answer? Okay, I'm giving you extra time. Try it. Just put. Okay, so here also put take a equal to 2. You can take it as a hint. Now try it. Should I do, or you are still trying to solve?
Still trying, sir.
Yeah, okay. Good. Do.
So for P
Yeah.
lesser than or equal to 1 it converges.
So for p less than equal to 1,
Does it converge?
okay, and p greater than 1 diverge, right? Sorry, p greater than 1 converge, right?
Yeah.
Okay, very good, Nina. What about Nina?
Yes, sir.
So have you able to solve this? Have you able to solve this or should I write it down?
Was able to solve it, sir.
Well, one.
So could you still solve it?
Yeah, sure. So, just look at 2 to the power f 2 to the power n. So this will be what? I mean, this will be 1 by n log 2 whole to the power p. And from previous problem, we see that this summation 1 by p to the power 1 by n to the p converge if p greater than 1 and diverge if p less than equal to 1. So that's it. Understand?
Yes.
Yeah. Now comes the following problem. Well, now this problem, I'm not going to say which theorem you are going to use or which test you are going to use. Just try to solve it by any test or by any theorem. So this for x greater than 0. Now comment on the converge of the series. X greater than 0 and x not equal to 1 by e. Now comment on the convergence of this series. First try. If you are not getting which test you need to apply, I will tell it. Then again, you should try. Try to let me know whether you are getting it or not. Devashri, would you please mute yourself? So, are you getting any way out? Or should I give you the hint? So let me know whether you're getting any idea how to approach this problem, or should I give the hint?
So I started with Cauchy's root test, but that's leading me nowhere. So maybe a hint would do.
Okay, so you are asking to use caution. So first of all, what is n factorial to 1 by n? Do you know it? Do you know this? I mean, what is the limiting value of n factorial to the power 1 by n? Do you know how to calculate it?
So, but, the unth term, how is it 2 power n?
Yeah, sorry, that's my mistake. It is n power n x to the 1 factorial n. Right. So the point is how to get the limiting value of this. So, mm, yeah. So, any idea how to get this limiting value, or should I give you the hint? Okay, but actually, your way is right. But the thing is, uh, getting this limiting value is difficult as far as the content has been done on your course. Okay, so the hint is apply the ratio test. So just apply the ratio test and let me know your progress. Okay. So as soon as you come up with some result, let me know. Let me know whether it
So if x is less than 1 by e, we get it to be convergent.
Yeah, it's less than 1 by convergent and greater than
X is,
divergent, right?
yes, sir.
Okay, very good. What about Nino?
Yes, sir. I'm getting it.
So you're still trying or you already get the answer?
This is. It looks like I get the same thing. Last few steps.
Okay,
Yes.
just finish it and let me know.
Yes, sir. Yes, sir. I'm getting the same.
Okay, good. So, going to the next problem. Mm, okay. So there is no concept of falling. Concept of falling problem. Let summation even be convergent series of positive real numbers that summation units are convergent. So Mega, can you try this? That given, so can you try it out? Just try it. If you are not getting the way out, let me know. I'll give you a hint. Then if you're stuck, then I will solve. Okay. So first try it out. Mega, are you trying?
Yes, sir.
Let me know. Okay, so the hint is comparison test. You somehow need to use a comparison test. So observe that there is no other sequence given only except the summation even. Okay. So you somehow need to comparison the sequence with itself in some clever way. So try it now.
So one part of the proof, I think it's pretty straightforward, but the other part is tough.
Other part means what? There is only one way that you need to prove the summation even square is convergent, right? So what do you mean the other part?
So I took. Uh, oh wait, my bad, my bad.
Okay, that's right.
So we can't say un square is greater than un for all n, right?
Yeah, right. So first of all, no need to do it for all n. If for some finite number of n it is not true, then it is okay. We can consider the terms after after those finite number of n's, right? I mean the point is that if you have a series u1, u2, u3 plus dot dot dot. But if first two terms u1 or u2 sum abruptly big, then it does not hamper the convergence of the series, right? So it does not matter that whether you need to get that for all n this should be less or this should be greater than. It's okay if some finite number of n are not satisfying these conditions. Okay, so just try, I think you are going in right direction. Just try again once. So you are trying, or should I do? Or you, if you want to try more, let me know.
I'm stuck right there.
Okay.
Even.
So the point is that since it is given that summation is convergent, this implies what? That limiting value of un is 0, right? So this implies un is less than 1 for all n greater than equal to k for some k, right? So multiply the un on both sides, un square minus un, and this happens for all n greater than equal to k. So now use the comparison test. So I mean, did you get the point?
So how did we say UN is less than N? I
Un is
mean
less
less
than 1.
than.
Yeah, because un is convergent, right? I mean, summation un is convergent, so un goes to 0, right?
Okay. Okay.
Okay. Okay. So it's a bit tricky, I understand, but anyway, no issue. So now the second question is that let summation un is convergent and un is greater than 0. Show that summation un by n, this is convergent. Okay, well, just as a hint, let me tell that it can be done by using the comparison test. Okay, so just try it, or else I will give one more hint. The question is, I'm repeating the question, is that given series un, summation un is convergent, and un are all positives, we need to show the summation un by n is convergent. Okay, let's try it.
So I'm getting UN by N is less than 1 by M, but 1 by N is not convergent.
Yeah, right. So another hint, that use APGP, that arithmetic progression, geometric progression inequality. Sorry, APGP inequality. Sorry, it's my mistake. It's AMGM inequality. Use it. So try to use the inequality somehow. Okay. So should I solve it or you are still trying?
Trying, sir.
Yeah, okay.
I'm stuck, sir.
Okay, no issue. So AMG inequality you need to use, so just directly using and look at this. So the point is that given that summation un convergent, so the previous one tells that summation un is convergent and also 1 by n square convergent. So this right side for this summation of un square plus 1 by n square, this thing convergent, and so this series un by n convergent. So do you understand? Let me know.
Oh, okay, okay. Yes.
So now should I shall I go to the next problem or you are writing it down?
2 seconds, sir. I'm writing it down.
Yeah, wait. Okay, okay. Sorry. Can I go to next problem? Because I need to scroll the screen up.
Yes, sir.
So So the following problem. Yeah. If summation is convergent and u1 is greater than 0, prove that summation un is also convergent. So the question says that even the summation is a given series which is convergent of positive real numbers. We need to prove that the series consisting of even terms of the given sequence will also converge. That's right. I mean, the hint is actually you just break down the summation, the series u to n, and use the fact that un is greater than 0. Okay. Just try it and try to use the comparison test. Let me know when if you are able to do this.
So we already, or otherwise, we already know that any subsequence of a sequence that converges will also converge. Can we use that?
No, because I mean, summation even and I mean un is convergent plus u2n convergent, that is okay, but here it is series. Okay.
Right, my bad. Yes. So we can write u2n plus u2n minus 1 is equal to un. So u2n will be lesser than un,
Yeah.
and then the ratio, I mean, the convergence, sorry,
Sorry,
comparison.
can you please repeat?
So we can write u2n
Yes.
plus u2n minus 1
Yes.
is equal to un.
It's called UN.
Summation of those, like summation of u2n. Yeah.
Yeah. Yeah. That's fine. Yeah. That's correct. Very good. So, okay. So moving to the next problem. So here also the same hypothesis that the series summation is convergent and union is greater than 0. Show that summation un by 1 plus un convergent. Just try it. Hint, the hint, you can use the following hint. The hint is use a limit test. Try it and let me know. I'll be back within 2 minutes. Are you able to solve this?
Yes, sir.
Yeah. So how?
So we take limit n tends to infinity of un by 1 plus un whole divided by un.
Yeah. Very good. Very nice.
So
So yeah.
can we do un by 1 plus un? Just by inspection, we know that that is lesser than un for any n.
Yeah, because un is greater than 0, right? So
Yeah,
obviously
that's
un by 1 plus un it is, mm, no, once again, just hold on. No, no. Directly by looking at this, it's not possible. I mean, by looking at examples, it's possible, but directly, theoretically, it's not possible. At least I think. Okay. But wait. If so, one second. Uh, so suppose we need to look at this. So no, un is greater than 0, so we can cancel it. So this is less than 1. This implies 1 plus un. Yeah, so your way is right. So we need to go in the backtrack. That is, we need to check un by 1 plus un is less than un. And this comes from the fact that 1 by 1 plus un is less than 1. And this comes from the fact that un greater than 0. So un greater than 0 implies this thing is less than even. Yeah, your way is very correct. Actually.
okay. But if we have to use that, we need to go from how you showed, like backtrack it.
Yeah, yeah.
Okay.
So, yeah. Okay, so consider this problem. So here the hypothesis is the same, that the given series is even convergent and un is greater than 0. And consider Vn is equal to u1 plus u2 plus un by n. Prove that summation Vn is divergent. Well, there actually nothing, we don't need anything about un. Just un is greater than 0 is enough, and Vn is the summation un by n. We need to check that Vn is a divergent series. Here just use the, you need to use the positivity of events, and then you need to use the comparison test. Try it or else let me know.
So by taking the second series to be 1 by n, can we do it?
Yeah, so your way is right. So can you explain it? Can you explain the whole solution?
Yes, sir. So we take summation un by n divided by 1 by n.
Yeah, then. So this is un, right? And this goes to 0. Yeah, but the point is un is divergent, right? Sorry, 1
Yes,
by
sir.
n is, but summation 1 by n is divergent. So directly it is not possible to say anything about un by n because this denominator is divergent, right? So here you
So,
need to, yeah. Yeah.
so but then it doesn't. Uh, we take limit of that, so it will be limit of summation un, not limit of un.
Oh, so basically you are asking. So this, right? So you're telling this.
Yes, sir.
Okay. So this is equal to nothing but u1 plus u2 plus un, right?
Yes, sir.
But how we can get limit from here? Is it possible? I mean, we need to get the limit now. So from this we can't get anything, right? So here is a very small trick. Just it's a matter of observation. Observe that v1 is equal to u1. Okay. v2 is equal to u1 plus u2 by 2, which is greater than u1 by 2. v3 is similarly greater than u1 by 3, right? So v1 plus v2 plus vn greater than u1 into 1 half 1 third 1 by, and this right side is divergent, so this the left side is divergent. Understand?
Okay. Yes.
Yeah, so it's actually 12. Now, what's it? So now going back to the first problem by which we have started, 1 by union plus 1. We have proved that this is convergent. Now, can you tell that how to show this convergence using these tests? So, do you understand the question? So, initially we have seen that this series is convergent and the value is 2 or 1 probably. But now using the tests, can you tell me that how we can show that this series is convergent?
Yes, sir. By comparison test, the other series we can use is 1 by n square.
Yeah, correct. So now there is one problem, another. Comment on the convergence of this following series summation 1 by n sine 1 by n. Summation 1 by n sine 1 by n.
Convergent, sir.
Yeah, how?
Oh no, wait. I took the other series to be 1 by n, and 1 by n sine 1 by n is less than 1 by n.
Yeah, right. That's very good. Yeah, correct. Well, so yeah. So well, so let's stop here. So if you have any short doubt in today's session, you can ask me in the next session. Okay. Thank you. So I am leaving the call.
Thank you, sir.